Hi everyone, this is your Aparna ma'am. Today we are going to switch on our concentration on one more important concept of nomenclature, that naming of alkenes and alkynes. In our previous video, we already studied about some basic rules for nomenclature of organic compound. So we move towards naming of alkenes and alkynes. Again, there are some rules such as select the longest carbon-carbon chain having maximum number of double or triple bonds, and during numbering, double and triple bond gets lowest locant. These two are important rule for numbering for naming the alkenes and alkynes. So we already know about alkenes, they have double bond, alkynes have a triple bond. So during selection of longest chain, your parent chain must contain double and triple bonds. And nomenclature has three parts: prefix, word root and suffix. Okay. Here one more important point is that if your compound contain both substituent double or triple bond, always preference goes to double and triple bond. Okay. Now we move towards example. Take down first example. In this example, what happens? 1, 2, 3, 4, 5. 5 carbon atoms are there. With respect to that, hydrogen atoms are also there. Okay. Means the compound is like this. What is first rule? First rule is that select the longest chain. Okay. So chain is like this. Only one chain, only one possibility is there. Therefore, this is a parent chain. Okay. And second rule is that numbering the carbon atom. Numbering of carbon atom done in such a way that the branching carbon atom or double bond carbon or triple bond carbon atom gets lowest possible number. So in this compound, one double bond is there that is attached to this carbon, between this carbon and this carbon. Therefore, numbering from right to left is correct. Why? Because 1, 2, 3, 4, 5. If we number like this, the double bond carbon atom gets lowest number. From left to right, what happens? 1, 2, 3, 4, 5 means locant is 4. From right to left, locant is 1. Therefore, nomenclature becomes nomenclature of this compound. In this compound, there is no prefix. Therefore, directly move towards word root. 1, 2, 3, 4, 5. Word root is pent. Okay. And suffix. Again, there are two types of suffixes: primary suffix and secondary suffix. Secondary suffix means functional group. In this compound, no functional group. Only primary suffix is there. That is in. Therefore, pent, ene. Name of compound is what? Pentene. Word root is pent. Suffix is ene. Is this clear to everyone? Listen once again. In this example, 1, 2, 3, 4, 5, 5 carbon atoms are there. Therefore, word root is pent. Is this clear? There is no prefix in the compound. Suffix is ene. Therefore, pent, ene. Between 1 and 2 double bond is there. Therefore, pentene or pent 1 ene. Is this clear to everyone? Yes. Next, we move towards this compound, bond line. Okay. Again, in this compound, how many number of carbon atoms are there? 1, 2, 1, 2, 3, 4, 5, 6. In this compound, numbering from left to right is correct. Why? Because double bond carbon atom gets the lowest possible number. This is our rule. Okay. So if we numbered right to left, what happens? 1, 2, 3, 4. Locant becomes what? 4. Okay. Left to right, 1, 2, 3, 4, 5. Between 2 and 3, double bond is there. Again, there is no prefix in the compound. Okay. Prefix is what? Which is not present in our parent chain is called as prefix. Yes or no? So in this compound, no prefix. Then directly move towards word root. 1, 2, 3, 4, 5, 6. 6 means hex. Okay. Hex. Between 2 and 3, double bond is there. Take a lowest number. Hex 2 ene. So nomenclature becomes hex 2 ene. Hex is a word root. Ene is a suffix. Again, in this compound, no prefix. Is this clear to everyone? Nomenclature has three parts: prefix, word root, suffix. Okay. In the given compound, there is no prefix. Therefore, directly move towards word root hex, and suffix is ene. Hex 2 ene. 2 means between 2 and 3 double bond is there. Therefore, take down 2. Is this clear to everyone? Next, we move towards third example. 1, 2, 3, 4, 5, 6, 7, 8. In the given compound, there are 8 carbon atoms. Okay. A second rule is what? Numbering the carbon atom. If we get confusion, then number from the both side After that you have to select the locants. Okay, 1 2 3 4 5 6 7 8. Okay, here locants are what? Between 2 and 3 double bond is there, therefore left to right locants are 2. Between 5 and 6 the double bond is there, 5. Here 2 and 3 triple bond is there, locant is what? 2. And between 5 and 6 double bond is there, locant is 5. So during numbering from left to right the locants are 2, 5. And right to left what happens? 1 2 3 4 5 6 7 8. 3 4, between 3 and 4 double bond is there, therefore locant is 3. Okay, 6 and 7 triple bond is there, locant is 6. Always we select minimum locant, smallest locant, lowest locant, sir. Therefore numbering from left to right is correct. Is this clear to everyone? Okay, numbering from left to right is correct. Left to right means for carbon number 2 triple bond, carbon number 5 double bond. Again there no prefix in the compound, therefore directly move towards word root. Word root is what? Oct. Word root is oct. Why? Because 8 carbon atoms are there in our chain. Okay, after word root we have to add suffix. There are two suffix "-ine" and "-ine". Okay, so 2-ine and 6-ine, sorry 5-ine. Between 5 and 6 means we have to take 5. Okay, so here "-ine" and "-ine" both are present. According to alphabetically order, E first comes, therefore first we have to write "-ine". Therefore 5-ine, 2-ine. Nomenclature becomes oct 5-ine 2-ine. Is this clear to everyone? Understood? Okay, next we have to move towards next example. Okay, same basic rule, apply the basic rule. What is first rule? Select the longest chain, only one chain is there. And second rule is that numbering the carbon atom, numbering is done in such a way that the double and triple bond carbon atom gets the lowest possible number. Okay, so numbering the carbon atom from the both side, 1 2 3 4 5. Okay, right to left what happens? Between 1 and 2 triple bond is there, take smallest number. Locants are what? 1, 4. 1, 4. Numbering from right to left, locants are 1, 4. Left to right, 1 2 3 4 5. Okay, left to right what happens? Double bond between 1 and 2, therefore locant is 1. Triple bond between 4 and 5, locant is 4. So in this case what happens? Locants are same. Left to right and right to left locants are same. At this time always preference goes to double bond compared to the triple bond. Means the double bond gets the lowest possible number. The lowest locant goes to the double bond. Is this clear to everyone? From left to right or left to right, right to left, if we get the same locants, then we have to follow this rule. Means preference goes to double bond. Is this clear? Means double bond gets the lowest possible number. Means numbering from left to right is correct. Then what is nomenclature? Again, first there is no prefix. Directly move towards word root. In the compound 5 carbon atoms are there. Therefore word root is pent. Word root is pent. Pent 1-ine and 4-ine. This is the nomenclature of given compound. Pent 1-ine 4-ine. 1-ine 4-ine. Again, while writing the nomenclature, always we follow the alphabetical order. Means the prefix or suffix which comes first in alphabetical order, we write first. Is this clear to everyone? Understood? And next we have to move towards next compound. In next compound what happens? There are 1 2 3 4 5 6 7 carbon atoms are there. Okay, numbering from right to left what happens? 1 2 3 4 5 6 7. Okay, between 1 and 2 triple bond is there, locant is 1. Between 5 and 6 double bond is there, locant is 1, 5. Here left to right what happens? 1 2 3 4 5 6 7. Okay, between 2 and 3 double bond is there, locant is 2. 2 and 3 double bond is there, and 6 and 7 triple bond is there, locant is 6. always preference goes to lowest locant, therefore 5 comma 6 is correct. Here 2 comma 6, this is 1 comma 5. Okay, 5 not 5 comma 6, sorry, 1 comma 5, here 2 comma 6, lowest locant rule, therefore 1 comma 5 is correct. 1 comma 5 means what? 1 comma 5, numbering from right to left is correct. Is this clear? Numbering from left to right, what happens? Locants are 2 comma 6. Always we must follow the lowest locant rule. Is this clear? Therefore numbering from right to left is correct. So in the compound, how many carbon atoms are there? 7 carbon atoms. Therefore word root is hept. 7 means hept. Okay, hept. Okay, in and ein both are there. First we write in. In is present in 5 in. Okay, and 1 ein. Hept 5 in 1 ein. Okay, we remove this last e because there is one more suffix, therefore we remove last e. Is this clear to everyone? Next we move towards one more important example. Okay, this one. Whatever may be the compound, we have to follow the same rules. Okay, first rule is what? Select the longest chain which has maximum number of double bond. 1 2 3 4, okay, 5 6 7. Okay, if we select the parent chain like this, 7 carbon atoms are there. Okay, one more possibility is there. 1 2 3 4 5 6 7. Okay, you have to select like this or like this, we get same number of carbon atoms. Okay, then again second rule is what? Numbering the carbon atom in such a way that the double bond carbon atom gets lowest possible number. Means we have to select the locant. Okay, if we number from right to left, what happens? The double bond carbon atom gets 1 comma 2, means 1 between 1 and 2 double bond is there. We have to select minimum number 1. Okay, between 5 6 and 7 double bond is there, 1 comma 6. So if we number from this side, what happens? 1 2 means between 1 and 2 double bond is there, 1 2 3 4 5 6, same locants. Okay, same locants. Therefore you select any numbering, left to right or right to left. Again here prefix is there. In this compound prefix is there. Prefix is the one which is not present in our parent chain is called as prefix. We already discussed in our last video. Please go through that video. Okay, then what is a prefix? Okay, 2 carbon atoms are there. In prefix 2 carbon atoms and double bond is there. Therefore prefix is eth, ene, yl. Ethene means double bond, 2 carbon atoms, ethene. Yl means it is attached to chain, therefore ethenyl. Ethenyl present in what? 1 2 3 4 5, fifth carbon atom. 1 2 3. Okay, here from this side what happens? 1 2 3, locant is 3, another prefix is attached to 3. 1 2 3 4 5, from right to left what happens? Prefix attached to 5. Always we select a minimum locant, means numbering from left to right is correct. Okay, double bond attached to 1 comma 6 1 comma 6, same, but prefix is present in carbon 3 from left to right. This is a prefix. Yes or no? Listen carefully, this is a prefix. Prefix present on carbon 3. Therefore nomenclature becomes, first we have to write prefix 3, eth, ene, yl. In parent chain 7 carbons are there, hept. Okay, 1 comma 6 diene, 2 double bonds are there, therefore diene. Is this clear? Understood? Okay, next we have to move towards this difficult example. Okay, again apply same rule. Select the longest chain. 1 2 3 4 5 6 7, one chain is there. 1 2 3 4 5 6 7 8 9. Okay, select the longest chain which has both double and triple bond. If we select the chain like this, okay, then here 2 carbon atoms are there. Prefix is ethyl. Here 1 2 3 4, 4 carbon atoms are there. Okay, prefix is what? Prefix is but. Prefix is but. Okay, 1 2 2 in yl. Okay, prefix is but 2 in yl. Okay, if this is our parent chain, listen carefully. What is remaining? Here 2 carbon atoms are there. Here 1 2 3 4. Okay, so nomenclature of this one becomes what? But-2-enyl. This is complex substituent. Okay, but-2-enyl. Therefore we have to write this complex substituent in bracket. Okay, if there is a biggest substituent, that is right in a bracket. Okay, then what about numbering? 1 2 3 4 5 6 7 8 9. Okay, triple bond between 1 and 2, therefore locant is 1. Double bond between 8 and 9, locant is 9. What about prefix 4 comma what 2, 4 comma 2, locants are 1 2 4 8. Okay, numbering from this side, what happens? 1 double bond carbon atom gets 1 2 3 4 5 6 7 8 9, 1 comma 8. Okay, 4 comma 6, 4 comma 6, 1 4 6 8. Here 1 2 4 8. Therefore numbering from this side is correct. Is this clear? Numbering from this side is correct. If we number from this side, locants are different, highest locants. If we number from this side, the locants are minimum anyhow. So what are locants? 1 2 4 8. Okay, prefixes are attached to 1 2 3. Okay, 3, not 4 again, 3. 1 2 3 4. Okay, therefore first we have to write prefix. Two prefixes are there. This is eth, alphabetically E, here alphabetically B. This prefix comes first, attached to what? 1 2 3, third carbon atom, this prefix is attached. Therefore 3 into bracket but-2-enyl. Okay, why inside bracket? Means this is a complex substituent. Complex substituents are right in bracket. Okay, after that what happens? 1 2 3 4 ethyl. Okay, word root is non. Between 4 and 8, double bond is there. 1 comma 8 between 1 and 8, 1 comma 8 diene. This is nomenclature of given compound. Okay, is this clear to everyone? So our nomenclature has 3 parts. What are those? Prefix, word root, suffix. And what are basic rules? Select the longest chain which has maximum number of double and triple bond. Numbering is done in such a way that the double bond and triple bond atom gets lowest possible number. If our compound contains both substituent, double bond and triple bond, always preference goes to double and triple bond. Means double and triple carbon atom gets lowest possible number. These are basic rules. You have to apply these rules, solve many number of examples, because this is a complex concept. After that you will get result. Okay, thank you very